Hello, welcome to Program with Sam, and this is Python Lesson 3. So today we're going to be looking at the object orientation that is available in Python. Now, with Python you have access to all of the object-oriented concepts like abstraction, inheritance, all done through your classes and instantiations of those classes called objects. It's very similar in terms of Java, but unlike Java, I would say that Python is probably actually more of an object-oriented language. And this is because Java has the primitive data types, whereas Python doesn't. Type checking is a little less tightly enforced, so to speak, in Python than it is in Java. For instance, you don't have to do variable type declarations in Python. The compiler figures that out once you're running your code. So I would say that in actuality, Python is more object-oriented than Java. So we're going to start by taking a look at class. Now this can be done by doing class and then student. Let's say we have a student, and let's have a person. Yeah, we'll have a person, and they can have then the initializer, the constructor, so to speak. And in Python, constructors are a little bit different to how we've seen before. So in Python, the constructor is actually defined as def init. So as you see there, that is the constructor for this object. And you'll notice that it's taking something called self. So this is the equivalent of the this keyword in Java, if you're familiar with that at all. And the reason you have to pass it is because that way the actual class knows which object it's acting on. When it comes to actually calling the function, you don't necessarily have to pass self at all. But it's just one of these things that needs to be included in the actual function definition here. Then we have to do self.name is equal to name, and self.job is equal to job. I mean, we could have something else in here as well. We could have age, and we could say self.age is equal to age. We could also have height for this person. Self.height is equal to height, and so on and so forth. You get the idea. And then when it comes to us instantiating the object, all we then do is person is equal to person, and maybe we say their name is Sam, their job is student, their age is 23, and their height is 6. Okay, so with that in mind, when it comes to actually running this, what we can then do is, to prove that it's worked, we could then say print person dot name, let's say. And then if we restart and run all, it prints out Sam because it's instantiated the object. And that's how sort of classes and instantiation works in Python. The next thing that we're going to be taking a look at is something called duck typing. Now this is a type system available in Python, whereby the type of the object is less important than the actual method that it defines. So this means that when the Python code is compiled, instead of checking for types, we're checking for method or attributes that the object has. So to put this in perspective for you, what I'll do is I will insert a cell below here, and I will have class animal, and this can have def underscore underscore init underscore underscore, and it will take self and it will take name, and then we just say self.name is equal to name. And so now both animal and person have name. So if now what I do is I come down here, insert cell below, and then we want to do list, or we'll say objects is equal to list, and we'll do objects dot append person, objects dot append, and then we need to do animal, and we'll call it cow, for instance. So what that will do when we run it, we'll have to run that, and then that, is it will create a list with a person in it and an animal. So what happens now if we go for O in objects and we just say print O.name. They're completely different objects, but they have the same field name. So if we run it, you'll see that both of them get printed out. There's no compiler error because both of them have that object name, and it works the same for methods. So if it doesn't have the same method or the same object, it would throw an error. So if we did job, for instance, cow doesn't have job, so it's going to error when it comes to animal. But because they have the same field name, both of those get printed out. And that's how duck typing works, essentially. So then the last thing to declare then, or to show off, is then how to define a method in a class. So for instance, this is done in the same way as you would define any method, just inside the class. So we do def show age or something like that. And then colon, and you just return age, self.age. It's important to remember that you're going to need to include self in the actual method definition. And then when it comes down to around here, we can then just do print person dot show age. And if we run that, it prints the 23. And that is how you then include methods in your classes. And that will wrap it up for this time. Next time, we're going to be looking at mathematical functions, pure functions, anonymous functions, and functional operations in Python. If you'd like to follow me at ProgramSamBlog or follow the blog directly at programwithsam.code.blog, that would be much appreciated. And I will see you in the next one.